Now we'll take up lens maker formula in this topic. Now this is a very useful equation and we are calling it lens maker formula. As the name suggests, this formula is used while designing lenses. Hence the name lens maker's formula. Let's consider thin double convex lens, and we are taking the refractive index of surrounding medium as mu1 and the refractive index of lens material as mu2. Please focus on the diagram shown on the screen. Now here we have marked different points, and O is indicating object and I is indicating the corresponding image. I1 is the image formed after refraction from the first surface, and C1 and C2 are center of curvatures. R1, R2 are radii of curvature of surfaces. So let's understand and let's go very slowly. The figure shown is very large, just to facilitate better understanding, but we have to keep it in mind. We are dealing with thin diverging lens and it is a double convex lens. The medium on both sides of lens is same and its refractive index is mu1. Now to trace the image, let's consider two refracted rays. One ray we have taken starting from O and it is along optical axis, so this ray will go without deviation. Now we are taking the second ray. The second ray originating from object O hits the first surface at point A1. We are calling it point of incidence. Now this ray is traveling from rarer to denser medium. It will bend towards normal and the corresponding angle of refraction we are marking it R1 and the angle of incidence we are denoting it by I1. Now this refracted ray on being produced, it meets optical axis at point which we are denoting it by I1. Now this is the image formed by first refracting surface and the angle made by the refracted ray with optical axis we are denoting it by beta 1. Now this ray travels into the lens and meets the second surface. Now the point of incidence at second surface we are denoting it by A2, and here the angle of incidence, that is with the normal, we are denoting it by I2 and the corresponding angle of refraction we are denoting it by R2, and the ray refracts out as it is moving from denser to rarer medium. It will bend away from the normal and this refracted ray will meet the optical axis at point which we are denoting it by I, which is the position of the image. Now the angle made by this refracted ray with optical axis we are denoting it by beta 1. We are dropping perpendicular from point of incidence on first surface, that is A1, on the optical axis, and we are calling the foot as M1. Similarly, we are dropping perpendicular from the second surface where the point of incidence is denoted by A2 and the corresponding foot on the optical axis we are denoting it by M2. R1, R2, U, V, these are as usual and these are clearly marked on the figure. Now we want to develop a relation which we are calling it lens maker's formula. Now let's take up the refraction at first surface and we apply Snell's law, and the Snell's law gives us mu1 sin I will be equal to mu2 sin R. Again reminding ourselves that we are dealing with paraxial rays, that means our angle of incidence and the corresponding angle of refraction are very small, so we can use small angle approximation, and that is sin theta as theta. So we can replace the Snell's law by another equation, that is mu1 r1 approximately equal to mu2 r1. Now here the important point is we have to replace I1 and R1 in terms of the angles we have marked. We have marked beta 1, beta 2, alpha. Alpha is the angle made by incident